To find the speed of a wave, we use v equals lambda times f. V for velocity, lambda is the wavelength, and f is the frequency. So velocity equals wavelength times the frequency. To find the speed of a wave, I have connected a power source to a motor, which spins a disc that is off-centered. Because the disc is off-centered, it causes the paddle connected here to this stick to vibrate in the water, creating waves. To measure the frequency, I will be using a tachometer, which measures revolutions per minute of a spinning object. The tachometer will be used to measure the revolutions per minute of the spinning disc. The disc has a piece of aluminum tape on it for the tachometer to read. The power source is turned on and the tachometer is used to measure the revolutions per minute of the spinning disc. In this case, it appears to be around 593 revolutions per minute. So, we have 593 revolutions per minute. To set this up, we will multiply by 1 minute per 60 seconds. Cancel out your units, and then you have 593 divided by 60, which equals 9.88 hertz. That is our frequency. We have now found the frequency of our equation. Next, we need to find lambda, or the wavelength. To find the wavelength, we start by measuring the distance between the paddle and a wooden block reference point. This distance is measured to be 19.8 centimeters. Next, the power source is turned on and a light is put above the glass tank to take a picture of the reflection of the waves. As shown here, 9 wavelengths were counted between the paddle and the wooden block reference point. So, we have 19.8 centimeters measured between the paddle and the wooden block reference point. Between the paddle and the wooden block reference point, we measured 9 wavelengths. So, we divide 19.8 centimeters by 9 wavelengths, and we have 2.2 centimeters per each wavelength. This is equal to 0.022 meters because there are 100 centimeters per meter, and this is our wavelength. Now, to solve for the velocity, we have velocity equals wavelength times the frequency. Our wavelength is 0.022 meters. Our frequency is 9.88 hertz. So, we take the wavelength times the frequency, so 0.022 meters times 9.88 hertz to give us the velocity. Multiply these out, and we get 0.217 meters per second. So the speed of the wave is 0.217 meters per second. For this next part of the lab, I will be looking at different wave interference patterns. For my first trial, I'll be looking at a single slit diffraction pattern, which should look something like this. A point light is casted over the glass tank, which has 2 wooden blocks in it to create a single slit. In the reflection from the waves, you can see the single slit opening and the diffraction pattern that follows. Next, we will be looking at a double slit diffraction pattern, which should look something like this. Once again, you can see in the reflection from a wave the double slit openings and the diffraction pattern that follows.